Bismillahirrahmanirrahim. Now we'll solve the problem of solubility. The Ksp of nickel sulfide NiS is 4 multiplied 10 raised to the power negative 20. So here I'll write the first given Ksp equals to 4 multiplied 10 power negative 20. After that, what is the concentration of sulfide ion? So here he asks you about the sulfide ion concentration, unknown in the saturated solution of nickel sulfide. So how we can solve this problem? The first step after writing the given, you write the balanced equation for solubility. So I'll write here nickel sulfide, and here the two ion can produces during solubility. Nickel ion plus sulfide ion. After that, here balance it. One nickel, one sulfur, one sulfur. After that, we can refer here for the concentration of nickel by X, and also here the concentration of sulfur with X, because here 1 mole, 1 mole. After that, I write the equation for Ksp. Ksp equal to the concentration of nickel multiplied by the concentration of sulfide ion. So here I'll write X for nickel multiplied by X of sulfur equal to X raised to the power 2. And the value here for Ksp 4 multiplied 10 raised to the power negative 20. After that, X here equals to 2 multiplied 10 power negative 10 molar. Okay, so here this value equal to the concentration of sulfide ion. So now here we finish the first problem. Here for the second problem, the Ksp of nickel sulfide is 4 multiplied 10 power negative 20. So I'll write here the given Ksp equals to 4 multiplied 10 raised to the power negative 20. What is the concentration of sulfide ion? So you will calculate the concentration of sulfide ion, unknown. In saturated solution of nickel sulfide to which 0.04 mole of nickel nitrate is added to, you have 0.04 mole of nickel nitrate is added. After that, I will write firstly the equation for solubility. So here you have nickel sulfide yield nickel ion plus sulfide ion. After that, you will refer for nickel by X and also sulfur for X. Okay, but here we'll add nickel nitrate. So here when you add nickel nitrate with 0.04, you will also add here for this nickel 0.04 plus this concentration. After that, here for the solubility, it will be 4 multiplied 10 power negative 20. So here this is the solubility constant very, very small. So we can neglect X, okay? So here we can neglect X. When you neglect X here, so the concentration of nickel equal to 0.04. So I'll write the equation for Ksp. Ksp here equal to the concentration of nickel multiplied by the concentration of sulfide ion. Okay, so here the Ksp equal 4 multiplied 10 raised to the power negative 20 equal to the nickel concentration 0.04 multiplied by concentration of sulfide ion unknown. Okay, so the concentration of sulfide ion here equals to, you will divide it 4 multiplied 10 power negative 20 by 0.04. So the answer it will be 1 multiplied 10 raised to the power negative 18 molar. So here this is the concentration of sulfide ion when you add 0.4 mole of nickel nitrate to nickel sulfide. Here for this problem, what is the approximate concentration of aluminum ion if the solubility product constant of ALOH by 3 is 27 multiplied 10 power negative 32? So firstly, I will write the given here from this problem as a Ksp KSP equals to 27 multiplied 10 raised to the power negative 32. After that, he asks you about the concentration of aluminum ion. So aluminum ion concentration unknown. After that, you will write firstly the equation explains the solubility. Okay, chemical equation explains the solubility. So here the AlOH by 3 yield Al positive 3 plus OH negative 1, this hydroxide ion. After that, let's balance the equation. Aluminium 1, aluminium 1. After that, hydroxide, here you have 3, here you have 1. So multiply this one by 3. After that, you will refer here for the concentration of aluminium by X. Here you have 3 of hydroxide, it referred by 3X. Let's here start here writing KSP equals to aluminium ion concentration multiplied by hydroxide ion concentration. But here it will be raised to the power 3. Why it will be raised to the power 3? Because you have here 3 moles. After that, here the aluminium, it will be X multiplied by, here it will be 3X raised to the power 3. And the value here for KSP, it will be 27 multiplied 10 raised to the power negative 32. So here you have 27 multiplied 10 power negative 32 equals to 27x raised to the power 4. After that, here x equals to 1 multiplied 10 raised to the power negative 8 here molar. This it will be the concentration of aluminum ion. Okay, so here this the final answer. Let's solve this problem. The solubility product constant of calcium hydroxide is 6 multiplied 6 raised to the power negative 6. So here you have KSP equals to 6 multiplied 10 raised to the power negative 6. If 0.1 mole of sodium hydroxide NaOH is added to 1 liter of 0.001 molarity calcium hydroxide, what is the final concentration of calcium ion? So he wants to calculate the concentration of calcium ion. Okay, the first step you write the equation. Here you write calcium hydroxide can be formed 2 ions calcium ion plus hydroxide ion negative 1. Here you have 2 hydroxides, so I'll put 2 here, 1 calcium, 1 calcium. After that, you refer for each one by X. So here, the calcium by X, and here it will be with the 2X because you have here 2. After that, I will write the KSP equal to the concentration of calcium multiplied by the concentration of hydroxide raised to the power 2. But here, the hydroxide, it will be common ion between this calcium hydroxide and sodium hydroxide. Here, the sodium hydroxide 0.1. So we'll add here for the hydroxide 0.1. Here, we cannot neglect X. Why? Because here the solubility not too much smaller. Okay. So I will refer here by 2x plus 0.1. After that, I will apply the KSP here equals 6 multiplied 10 raised to the power negative 6 equal to calcium, it will be x multiplied by 2x plus 0.1, all of them raised to the power 2. After that, by using the mathematical means to solve this equation, you'll find here x equals to 6.5 multiplied 10 raised to the power negative 4 molar. This it would be the concentration of calcium ion. Okay, so here you calculate the concentration here. if you will add of calcium ion, if you add 0.1 mole of sodium hydroxide to this saturated solution. Now we solve the problem of the equilibrium constant. Okay, here calculate the concentration of hydrogen iodide when the equilibrium constant is 1 multiplied 10 power 5. So the hydrogen iodide concentration unknown, you will calculate it. So hydrogen iodide unknown, and here the K equilibrium, okay, equals to 1 multiplied 10 raised to the power 5. The equilibrium concentration of hydrogen, so the hydrogen concentration equals to 0.04 molar, and the iodine concentration equals to 0.009 molar. After that, you will write the equation. Here we will write the equation for the hydrogen iodide formation. It will be hydrogen plus iodine yields hydrogen iodide. But this equation not balanced. Here we have two iodine, here we have one. So I'll multiply all this one by 2. This 2 multiplied for hydrogen and the 2 for iodine. After that, here you have 2 hydrogen, 2 iodine. After that, I'll write K equilibrium. K equilibrium equal to the concentration of product divided the concentration of reactant. So here you have hydrogen iodide concentration raised to the power 2 divided by hydrogen concentration multiplied by iodine concentration. After that, here you have the K equilibrium and you have the concentration of hydrogen and the concentration of iodine. So I'll write 1 multiplied 10 raised to the power 5 equals to hydrogen iodide raised to the power 2 divided by hydrogen equal to 0.04 multiplied by 0.009 for iodine. After that, the hydrogen iodide concentration, okay, equals to 6 molar. So here, by using the equilibrium constant, you can calculate the concentration of one of the product or reactant. Okay, by using the equation K equilibrium equal to the concentration of product divided the concentration of reactant.